Moving products from a point of origin to a final destination requires a massive orchestration of physical infrastructure, labor, and fuel. When evaluating how effectively that system operates, a common baseline assumption in business is that a standard product margin accurately reflects overall profitability. If an item costs $10 to manufacture and sells for $20, the gross margin is assumed to be stable. Traditional accounting practices often reinforce this by taking total logistics expenses, warehousing, transport, and handling, and averaging them evenly across all clients and orders. This obscures the actual resource consumption occurring on the warehouse floor. Cost to serve, or CTS, replaces that average with precision. It is a specific metric that calculates the exact volume of resources required to deliver a product to a specific destination. Instead of measuring the product itself, it measures the demand scenario. You can analyze individual customers, distinct sales channels, specific order types, or broader product segments. Moving from an assumed average cost to a calculated actual cost allows an organization to identify which segments of their supply chain are generating profit and which are eroding it. Rather than treating logistics as a static overhead entry, managers apply CTS as a framework for operational intervention. This framework serves four purposes. First, it determines exact customer profitability. Second, it identifies specific hidden cost drivers. Third, it provides data to support complex pricing decisions. Fourth, it aligns supply chain design with customer segmentation. These four applications shift the focus towards service-level decisions, the specific operational choices made to fulfill a request. When these four categories are measured, the supply chain functions as a map for strategic network design, directing resources to where they are most efficient. To see how demand patterns manipulate margins, consider a manufacturer supplying two different retailers with the exact same physical product. This table outlines our scenario. Retailer A operates with a highly predictable order pattern, placing large volume requests on a weekly basis. Because the manufacturer can plan ahead and ship in bulk, Retailer A incurs a low transport cost. The resulting profitability is high. Contrast that with Retailer B. They buy the exact same item, but their pattern consists of daily, small batch orders. That frequency drives up transport costs severely. The physical product is identical, but Retailer B yields low profitability. You see the same disparity when comparing wholesale distribution to e-commerce. A distributor buying full pallet loads requires minimal handling. An online customer demands individual home delivery, which increases the costs for warehouse picking and specialized packaging. Because demand patterns dictate logistics costs, the cost to serve per unit fluctuates, making identical products perform differently in terms of final profit. Accurately measuring these disparities requires mapping the entire life cycle of a fulfilled order, dividing the process into four structural components. The first component captures upstream costs. This accounts for the initial procurement of materials and the specific production setup required for the order. Next is internal handling. This measures the specific warehouse labor utilized, tracking the time spent on order picking and custom packaging. The third pillar is distribution. It accounts for primary transportation, the complexity of last-mile delivery, and the processing required for any returns. Finally, we have service costs. This tracks direct customer support and costs associated with special requirements, like rush orders or custom crating. These four pillars represent an end-to-end measurement across the supply chain. They capture operational activities that occur far beyond standard manufacturing overhead. If a business fails to track expenses across all four of these categories, their view of total operational expenditure is likely to be inaccurate. To function correctly, a CTS framework must be customer-specific and linked directly to operational actions. This relies on the principle of activity-based costing. Under this rule, costs are assigned exactly to the operational activities that generate them. Traditional accounting takes logistics spend and averages it across all clients, treating a difficult buyer the same as an efficient one. Activity-based costing isolates the difficult buyer and assigns the premium cost directly to the activities they trigger. This enforces a core law of logistics, the service cost trade-off. Providing higher service levels results in a higher cost to serve. To manage this trade-off, managers use supply chain segmentation. Because different customers demand different service levels, they require different physical supply chain designs. Recognizing these principles shifts logistics from a rigid, single-path operation into a segmented strategy. In practice, managers use CTS data to dictate real-world strategic decisions. This strategy matrix demonstrates how companies segment their customer base once profitability is calculated. For segments yielding high profit, the company assigns a premium service strategy to protect the account. For low-profit segments, managers have two interventions. They must either reduce the service level provided or increase the price to the customer. CTS also influences physical distribution networks. If data shows long transport runs are eroding margins, a company might consolidate shipments to run less frequently or utilize a regional warehouse closer to the demand base. It also directly dictates pricing logic. CTS provides the basis for implementing delivery fees, minimum order quantities, and surcharges for rush orders. Ultimately, CTS provides the evidence needed to charge for inefficient purchasing behaviors and reward profitable ones. While the math behind activity-based costing is logical, executing it accurately within a large corporation is difficult. The primary barrier is data fragmentation. Procurement, warehousing, and transport often run on separate software systems, making it difficult to trace a single dollar's journey across the fulfillment cycle. There is also an internal human element. Organizations often resist changing legacy customer service policies, even when the data proves those accounts are losing money. To bypass these barriers, supply chains are deploying advanced analytics and AI platforms specifically designed for dynamic CTS modeling. These systems ingest fragmented data streams to provide managers with real-time visibility into their actual cost drivers. Overcoming these technical challenges allows companies to achieve customer-centric service designs that are aligned with their financial goals. The most persistent error in supply chain management is equating cost to serve with the manufacturing cost of the product. They are distinct metrics. Operating under the assumption that all customers should receive the exact same level of service often means that high-maintenance buyers are subsidized by efficient ones. This concluding takeaway block strips the concept down to its absolute core. Revenue does not equal profit unless the specific service cost to acquire that revenue is fully understood. Cost to serve provides the mathematical evidence required to align physical operations with financial targets, ensuring that every delivery is priced according to its actual resource consumption.